Hey, I'm Geoff with Wisycom USA. Today I'm here with Dave Martin, Project Manager of JetWave Wireless.
Hey.
Thank you so much for being with us today, Dave.
Yeah, totally.
Today we're going to talk about the BFA and LFA. These are Wisycom's amplified filters. The LFA is a filtered antenna based off a log periodic design, and the BFA is an inline filter, an amp. So what these offer are a minus 12 dB pad up to a plus 27 boost, as well as a selectable low pass, high pass filters, and a 40 meg wide tunable bandpass filter. So Dave, let's talk about what we're looking at here on the spectrum analyzer and behind us.
So what we've got up on the screen here, we are running a tracking generator through this BFA here. Off the screen, we do have a 288 kind of as a hub here that will allow us to switch between these two antennas and what it's feeding here. But the 288 at this point is adding no gain. We're just using it as a transparent device.
And we're just using, so just adding bias with it. So
what we're looking at is the BFA with the wideband filter set to the full wideband that's available today, 470 to 698. And so we can start to see the slope starts about here and about here. Our total spans 800 meg, but we're almost looking at 200 meg to a gig at the far end. And we can see our filter window from 470 to 698 right there in the middle of the screen.
So we talked about a pad and an amplifier.
Yep.
So right now we have a tracking generator pushing through the device. Can you explain a little bit for someone who doesn't know what that means, kind of what the tracking generator does?
So the tracking generator essentially tricks the view of the spectrum analyzer to see a full bandwidth signal. So it's very handy for sweeping things like filters because it will show you where your filter windows are. You can look at your roll off. But what is going on is it's actually a signal generation that sweeps along with the analyzer. Our viewers may be able to see the sweep actually move along at the bottom. Doing a sweep like this without any antenna hooked up, we're just going right in, right out, we don't see a lot of change. On an antenna, you'll actually see things pump up and down, and you'll see it right across the screen.
And as we change some settings on the BFA, that will show that way that it's a little delayed sometimes in what we click.
Yeah, we can actually watch it write it to the screen in real time, which I think helps tell the story really well.
So let's start with the amplification and pads.
Yep.
So right now we're at 0 dB on the BFA. So this is where you'd start with any kind of amplified device in an RF system.
Yeah.
So let's show kind of what this looks like as you're taking it up and down.
So I'm gonna wake this guy up, and we'll just go into the main menu and hit the gain section. So let's reel off 6 dB here. This will update live. If I don't save it though, it's gonna kick back out and it'll just go right back to where it was. So I'm gonna press and hold menu select. And now this is saved. We can see the sweep's not updating anymore, but we're now at minus 6 dB. Going even further down from that, we can take it down to 12 and watch that happen again. So there we are, minus 12 dB. So we can see in our divisions here, this is minus 37, this is minus 47. That's 10 dB for that box, so that translates pretty well. We'll go back in and pump that right up to 0.
And you'll see this change in real time as it catches up to what we've done.
There you go, that's 0. I overshot a little bit. But we can see we've now picked up essentially about a box height here. So each of these divisions is our 10 dB there.
So now, Dave, let's put this into what we talked about earlier is the electronically tunable bandpass filter.
Yeah, so we'll go down to the filter, pop in there, and then we are going to tunable.
So what we're looking at here is a 568 to 608, which is kind of at the very top end of what's going to be left in the lower part of UHF. So let's do a radical shift and kind of show what happens if we push this all the way down to say start at 470.
So let me see if I can punch down there fast enough. So there you go.
And once we save, you'll see this update on the analyzer.
480 to 520. So now we just saw the sweep catch up, and there's our new bandpass window.
Both the BFA and LFA allow you to change this tunable window in 1 megahertz steps. So whichever environment or whichever market you're in, you can keep your mics inside of this window.
Yeah, 40 can usually cover most of your needs. There will be some really big shows where you're not going to be able to pack everything in there, or you're dealing with mixed brands, different bands, and that can sometimes spread you out a little more. But if it's all your mics, especially in E&G situations, you're definitely going to be covered by these filter windows.
While we're talking about different brands, a question that comes up that this will pass RF from any brand or any device, whether it's analog or digital.
Yep.
The great thing about Wisycom is a really omni brand when it comes to passing RF.
That's the great thing about Wisycom distribution products. They can be used with any brand out there. Doesn't matter if it's analog, digital mics, it's still going to pass the RF through to them.
So that makes the Wisycom RF distribution products a great tool on any job. So let's talk about the LFA now.
Okay.
The LFA is the log periodic, and as we'll pull that out on our table here, we've also got this running through our MAT288 just to deliver bias and just to act as a hub for our RF here. So you'll see what happens when we deselect it from the MAT. The BFA will turn off and the LFA will come to life. So Dave, let's pick up here with the LFA.
Yep.
We've shrunk our spectrum analyzer down a little bit.
Considerably, yeah.
Consider from an 800 meg span down to a 20 meg span with a center frequency of 560.
Yep.
So here we have my mic, your mic, and a spare mic that's in your back pocket.
Yep.
And these are pretty clean linear carriers. We've got a lot of space between the carrier and the noise floor.
Yep. And that is really all the receiver is ever going to see. The signal to noise makes up the entirety of what the receiver is picking off and creating your audio with.
So let's talk about boost. We talked a little bit about pads in the BFA. So let's talk about what happens as you amplify this antenna up. Because the LFA and the BFA both go from a -12 pad up to a +27.
+27 is a lot. Yeah.
+27 is a very large amount of boost,
Yep.
which let's talk about, is there any situation in your professional career where you've needed +27 or that would be a value?
+27 is really high. I don't know that I've ever needed that much gain. More often than not, I'm using my gain in intervals of 3 because that's how much loss I face with the coax we use. The particular coax we use, you see about 2.7, 2.8 dB of loss per 100 feet. And that's my normal math. If I'm running out 250 feet, I'm going to dial up the gain just to overcome that. More often than not, though, I do find myself padding. So that's definitely a handy tool to have on there. But it's usually about cable loss. Rarely, if you're trying to make a really ambitious hop from your talent back to your antenna, you might pump up the gain a little bit. As we'll show you in a second, though, everything is a trade-off. So with increased gain, sometimes comes increased noise. And as we increase that noise, we're actually shrinking our signal to noise, and in turn, making it harder for the receiver to do its job. So let's go ahead and crank some gain and pull some out and just kind of see what we end up with on here. So right now, the screen is timed out. We can see from the LED that it is on and doing its job. So we wake it up to the main menu. I can see that this has a wideband filter with this is one of the low pass filters, dropping everything off below 600. And here in the States, down to 470, other markets are gonna be a little bit different. But let's go ahead and punch into the main menu and grab the gain here. So we can crank the gain up and down and see the mics move in real time. So I'm coming down. This is now at -7. Let's go ahead and create a problem. So we are driving all of about 6 feet of cable here. This is RG58, so it is considerably lossier than the cable I was describing, but we can very quickly overdrive this. We start to see some distortion down here and distortion between the carriers.
And overall, we're seeing our noise floor just across just what we're looking at start to pick up as well.
Right, and you do get to a point where your amplitude overall for your RF carriers won't actually get any higher, and you're just increasing noise.
For example, our spectrum analyzer is already clipping out what it's seeing, and
Yeah, so this is a complete oversaturation of the input here, and we're starting to see a number of harmonics and other products of distortion in here. And now we hear
a little beeping is just our analyzer max gain. That's only at about plus 18 gain.
Now, yeah, and plus 18, that would be enough to drive a considerable amount of copper.
And in any location ENG, field usage, your receiver isn't going to have the same sensitivity as, say, this analyzer is. It's not going to tell you that it's overloading.
No, a good way to see if you've driven too much gain from your antennas, especially an active antenna and a smart antenna like this one, is to actually power your transmitters off and take a look at the RF levels on your receiver. If you're still seeing a considerable amount of RF energy there with no transmitter there, you're looking at noise. And that's a good indicator of, have I gotten too far?
So let's look, Dave. Right now we've got this on the wideband setting. So if we switch this over to the tunable setting, and these three mics are outside of the window, let's look at what it does to these carriers.
Okay, and that's a great example of why you'd want such tight band passes. If you're in an environment with a lot of users and a lot of different types of wireless, it may not be wireless you're after. So let's go ahead and take our filter to tunable. We'll go ahead and save this. And this is actually still pretty close to our window. We're within a few meg of our mics. So the slope of the filter is still gonna allow our mics in. So let's go for a drastic change and go similar to what we did with the BFA and take this way down into the upper 400s, lower 5s. So we're now over 50 meg out from our mics. We'll save that. So we saw a considerable drop of energy. We're getting a lot of energy in here because we're talking about free space of 18 inches from these microphones to here.
To learn more about what free space and free space path loss means, you could check out a video that Nick Marley and Jim Dugan did talking about how far will your mic go.
So I'm gonna go ahead and put this back in wideband mode.
And you can immediately see our carriers shoot back up to strong signals.
Promptly return back to life.
So that's just a little bit about the BFA and LFA. And really the BFA and LFA are the same device. The LFA is just strapped onto basically an LBN2 antenna.
Yep.
And the BFA is an inline.
Yep.
So I hope that answers some questions and tells you some things you might not have known about the BFA and LFA. Dave, thanks again for being with us and talking about this with us.
Yeah, absolutely.
If there's anything else we can answer questions for you about or anything you'd like us to discuss in an upcoming video, let us know. Support@wisycomusa.com.